Hi. So e-wallpaper is quite simply a sheet of wallpaper with a couple thousand processors embedded in the wallpaper. Now, each processor also has its own radio transceiver and antenna, and these 16,000 processors are connected together in a 2D mesh network. Now, for this project, we developed a radar imaging algorithm that allows us to form a 3D image of the room using the radio transceivers on each processor. How it works is that each transceiver transmits a millimeter wave radio pulse into the room and then records the responses from the objects in the room. And we then developed our own algorithm based on synthetic aperture radar that allows us to combine these responses to form a complete image. Now, there were a number of challenges in making this algorithm work. The first challenge is that the responses at each antenna are distributed amongst the 16,000 CPUs rather than being stored in a single node. We also have only a 2D mesh network, and this makes moving the data around fairly difficult. And lastly, each CPU only has about 100 kilobytes of memory available, so you can't store the entire data set on one node.
So we developed a distributed version of the SAR algorithm to overcome these challenges. So to test our algorithm, we simulated the antenna response reflecting off an artificial scene, such as the sphere of points. These antenna responses into our algorithm, which we ran on Hopper. And this image shows the reconstructed 3D image of the scene. These graphs on the right show the projected performance of the algorithm on running on the actual eWallpaper hardware. So for our proposed 128 by 128 antenna resolution, we have a parallel speedup of about 600 times over a naive serial implementation. And at the proposed 1 gigabit per second link bandwidth, we achieve 75 frames per second frame rate. And this allows us to do low latency human gesture recognition. If you're interested, please come stop by our fester. Thank you.
So this is the next version of Kinect. So, okay.
Or Big Brother.
Yes.